And in previous video, what we did is we transformed the Lagrangian coordinate to polar coordinates. So what we are going to do now is we have a polar coordinate Lagrangian. We have to transform that into uh, Hamiltonian with the help of a Legendre transform, right? So these are the things which you need while transforming the given Lagrangian into Hamiltonian, right? So let's get into the uh, idea today. So here we have uh, the Lagrangian. Just a minute. So we have a Lagrangian, so which is given as of m dot square plus r square theta dot square, and we have a potential which is a function of r and theta, right? Then we have to now not transform this L to H, right? We have to perform Legendre transformation. As we discussed in previous video, uh, you know what is the Legendre transformations, right? So in order to transform from L to H, we have to convert this QI dots into uh, Q and P's. Here we have L, this is a function of R, theta, R dot, and theta dot, and we have to transform this into H, this R, theta, PR, and P theta. So Hamiltonian must contain R and P's. Right here we have R theta, R and theta. So we have PR and P theta. Right. So in order to find the transform this, we need to find generalized momenta. Generalized momenta. Right. In general, the generalized momenta, which is given as Pi equal to dou L by dou Qi dot. Here we have two coordinates, right, which is r and theta. So I can write PR, which is equal to dou L by dou R. So since we have L here, we have the Lagrangian, right? So we write PR, which is equal to mr dot, right? So we know PR is equal to mr dot now. So I can just rearrange that as r dot equal to PR by m. We need this now to make a Legendre transformation. This is a one term, this is a R and PR and R dot is related. Right? So in order to transform this R dot to PR, we can use this. Right? Similarly for theta, so P theta equal to dou L by dou theta. So we can write, so P theta equal to mr square theta dot. So only theta dot term is present in this term. So we can just P, theta is the subscript, right? So mr square theta dot, and once we rearrange for theta dot, we are able to get p theta by mr square. So this is the another term which we have to replace in the place of theta dot to write in terms of p theta, right? So once we have this, we are able to write the Legendre transformation now, right? So H, which is equal to PIQI dot minus L. So here we have two terms, right? So PR R dot minus P theta dot minus L. It should be a function of R theta, PR and P theta. For the time being, I am writing R theta R dot. In next step itself, we will transform this, right? So we know this is the Legendre transformation, which is such as equal to PQI dot PIQI dot ui dot is given here, right? That is ui dot minus l. So h is equal to, we have PR here, which is completely okay because we R h is a function of PR, and instead of R dot we have to replace it by PR divided by M, and minus P theta, theta dot is replaced by P theta divided by M R square, minus we have L here, 1 by 2 M R dot square plus R square theta dot square minus V is a function of R comma t, right? So what we do now is we just combine this term. We can write it as PR square by M minus P theta square by M R square minus 1 by 2, and this should be plus here because we have a minus sign in this equation. Once you multiply it by minus, this will become plus. So 1 by 2, there's a M R dot square can be replaced with the as PR square divided by M square, right? Then we have another term here, so minus 1 by 2 M R square, theta dot square is written as P theta square divided by M square R power 4. So just we are squaring this term, theta dot square, which is equal to P theta square divided by M square R power 4, right? So we have this terms and this term separately, and we have a potential which is V is a function. It depends on the given potential. So once you see this, we can strike out some common terms here, right? So we have M square here, R square, R power 4 here, this will become 2. So I can write H is equal to PR square by M minus P theta square by M R square minus 1 by 2 PR square M PR square M minus 1 by 2 P theta square by M R square plus VR theta. So I think I made a mistake in somewhere. So here I have a mistake. So this would be plus P. Yeah, that's correct. Right. So this is 1 PR square by M and 1 P theta square by M R square. Here we have off. So we can write it as PR square by 2M plus P theta square by 2MR square, and plus VR theta. Then we write H is equal to 1 by, we can take 1 by 2M in common. So PR square plus P theta square by R square plus V of R theta. This is what the Legendre transformation for the polar coordinate Lagrange. It's a general term. Okay, once we get into the problem, we will use this. So we will end this video by this. For the time being, we'll end up this video. Then we will extend this to some problems.